Cool. Hi everyone, I'm here to talk about Ophyd v2, which is a library in development by these people. That's going to take some practice. Predominantly my colleague Tom Cobb at Diamond Light Source, but also with significant input from NSLS-II, the originators of the Bluesky framework, of which this is a part. This is a fairly technical talk, which I imagine is why it's ended up in the software development section, but I'm going to start with a broad overview of the software that NSLS-II developed, the software that we have developed, the reasons why we might want to combine it, spoiler alert, zoom out a bit and talk about the current state of the Bluesky collaboration, because there's a few interesting things going on there. And then most of the time I will be covering the problems and solutions that we have each encountered as facilities and the reasons why we have decided to come together to develop a library to solve them. So just to quickly sort of introduce software, Pete from the APS kindly introduced pretty much everything I was going to talk about yesterday in his talk, so I can kind of whiz through this bit. But what is Ophyd? It's a hardware abstraction layer for Bluesky, written in Python. I have a motor called X. I can set its position. I can read its position. I can subscribe to its position. Yes, exactly as it says there, hardware abstraction layer focused on data acquisition. From the Diamond point of view, we developed a piece of software called Malcolm, which was a bit more focused than Ophyd, which is of course focused on controlling all hardware for scans and orchestration of all types. Malcolm is specifically aimed at hardware triggered scanning, fly scanning, various terms have been thrown around, and is a fully fledged service rather than a library, providing a map of the hardware in a hierarchy of devices, devices being in quotes because some of them are not devices, they are virtual devices, just containers for logic. More on that later, and all sorts of handy features like a configuration UI. So Ophyd v2 is an amalgamation of Ophyd and Malcolm, incorporating lessons learned from both and jointly developed by NSLS-II and Diamond. Our key design concerns, which I've listed there, modularity, clear migration path, because you don't want, if you just try and develop a new library and drop the existing one, no one's going to adopt it. And separation of logic and I/O, we'll get to that, and easy to implement hardware triggered scanning solutions. So this is something that Ophyd v1, the current version, struggles with a bit. And so we were hoping to bring our expertise to that. Before I get into the technical aspects, I wanted to just quickly say a few things about the Bluesky collaboration as it stands. So Bluesky, as Peter alluded to yesterday, is a collection of libraries. It's a toolbox, as NSLS-II called it, which they developed around 8 years ago. And they tend to peddle out this diagram whenever they talk about it. Ophyd is currently here, Python abstractions of hardware, and is at a fairly low level. So this talk is generally aimed at developers like ourselves and what I would call power users. Recently, we've appointed a technical steering committee for the Bluesky project, which consists of a few representatives from a few facilities with reasonable technical expertise who essentially get a vote on large decisions that may affect the whole framework. And this is the most up-to-date list NSLS-II could give me of facilities that are currently using it in various forms, everything from sort of evaluation to full adoption. Okay, so how did we get to Ophyd 2? What problems were there? What solutions have we come up with? I'm going to start with one of Diamond's problems, scattered scan logic. So I mentioned the hierarchy of devices in our Malcolm software earlier. Each component of the hierarchy contains a little chunk of logic. This becomes very hard to reason about when you're reading code because you kind of compose these chunks together later on and you're not really sure what's going on. Will it be invoking this now? No, yes, maybe. Will it be invoking this before this? That sort of thing. To make matters worse, Malcolm is not all we do because it only does fly scanning and we want to do step scanning sometimes. So we have a separate system for that, GDA. Worse than that, they're written in different languages. So getting them to talk to each other and work together has always been a bit of a nightmare. It's had a lot of failure modes, shared state over network interface, duplication, etc. So we've always been hoping to unify under one banner, and Bluesky presented that opportunity for us, a single framework for all of our scans. We liked these things about it, basically lightweight, clean architecture based on modern Python 3, which most people seem to agree is the way forward for science these days. The pub sub event model for data, the fact that it is a toolbox and you can just pick out the modules you like, which is particularly useful in this case, as we'll see in a minute, and the fact that it's in use in other places. And if we wanted to write something ourselves, we'd just be duplicating existing work. What was the problem from NSLS-II's point of view? The Ophyd code base is getting old. It's one of the oldest in the Bluesky framework, dating back to just before 2015, as we see there. Been a lot of lessons learned since then. There's a lot of backwards compatibility to maintain. It becomes hard to advance it forward and, for example, develop a consistent solution for fly scanning. So they like the idea of developing a brand new package as well. The good thing about this is that Bluesky has a series of interfaces that devices must obey. And what that means is this isn't an either or thing. You don't have to have Ophyd 1 or 2. You just need objects that obey the interfaces. So you can have a mix, and that provides you with an agile migration path because you only need to port devices as and when you need them. And that comes back to what I mentioned. If you tell people to completely move all of their equipment over in one day, they're not going to do it, and rightly so. What also appealed to NSLS-II, as well as us, was the potential for modern quality assurance with modern Python 3, etc. So MyPy, Black, etc. tools that we have all become used to with new projects these days. Going back to Diamond and Malcolm, we had the problem of an abstract device tree. These are all parts of Malcolm. One of them might be a motor or a detector, for example. It's not really easy to figure out which one. It's that one, but that wasn't obvious. So we quite like the Bluesky protocols, the interfaces I mentioned that objects must obey, because they are more understandable and more reasonable. So readable, movable, and flyable being the main ones. And for our fly scanning case, flyable. The other problem that Ophyd has at the moment is the coupling of I/O code and logic. So an Ophyd device will make out calls to the hardware, and in between these calls, it may do some calculations, it may do some amalgamation of data. And if you want to configure your devices in different ways, this rapidly becomes very complicated. The kind of go-to solution is multiple inheritance in Python. So writing small classes that are completely useless on their own and stitching them together a bit later on, depending on exactly how you want your code to run. The example we've got here is Panda. Another good example that's been mentioned a few times is area detector. There are many ways to control an area detector. There are many triggering schemes, and people tend to write multiple Ophyd devices for one detector and use the one that's most appropriate to their needs at the time. It's complicated, and especially once you bring in the inheritance, you can end up with your classic diamond dependency problem. And more generally, I think the community is starting to agree that inheritance is bad. So the solution we like is also the generally agreed thing: composition over inheritance. The idea of creating a single object encapsulating just the comms functionality with no logic in it, and wrapping it with n, i.e. one or more objects that actually know how to operate the hardware. So the area detector case again, you can imagine a single object to talk to a detector and many wrapper objects to run it different ways. The Panda case, we have a single object to talk to Panda and many possible wrapper objects depending on how you wish to trigger your hardware. We also took the opportunity to adopt async I/O with the Diamond developed library IOCA for talking to epics in hopes of performance gains, which so far seems promising. The other major issue that we wanted to address with Ophyd was PDs, prefixes, suffixes, etc. being hard-coded. So this is an extract from the source code for area detector in Ophyd, that is. The area detector wrapper in Ophyd. I've been caught out on this. And so you may well recognize PD names or parts of PD names hard-coded in here. This can cause issues. For example, what if these change, or a facility uses a non-standard naming convention? There are all sorts of possibilities. So we wanted to decouple this and create a new component for supplying PV names, or I'll say signal definitions, because Ophyd signals don't have to be PVs. Ophyd happens to be aimed at epics, but can be re-implemented on top of other control systems. So we've written a new component called a signal collector, which can provide definitions to a device, and depending on how you configure it, can get those definitions from multiple possible places. Perhaps they are hard-coded in a different place. Perhaps we've written some functions to define the naming convention, or perhaps we've made use of some external storage systems. So PVI is a project in development by Diamond to create a PV of PVs for certain IOCs. And then, yeah, alternatively, there's the database of your choice. So where is Ophyd v2 at the moment? It's in early alpha. We've developed a library to model the hardware triggered scans. It's called ScanSpec. That's a plot from it of a trajectory scan. And Ophyd v2 is currently being merged into a package in the main Ophyd repository. So eager early adopters will get the opportunity to play with it relatively soon. I believe Tom back home is currently working on this issue, updating the build system. He's also started on separating Ophyd devices out into separate repositories to avoid the code load that we've had before. Back to the previous problem slides. And that's pretty much it, really. This is where we are. This is very early days. We're very keen for collaboration, early adoption, testing, etc. We are incorporating lessons learned. Our priority, like I say, is the migration path, is making sure that we can make something that adds to what's there and can be easily used without compromising the existing code bases. Probably also important to emphasize that this isn't something Diamond's gone off and done on our own. We are talking with NSLS-II regularly, and we get quite a bit of looking from other people. I want to mention PSI because they've now started joining us every 2 weeks, and the University of Wisconsin Medicine, who've contributed quite a bit to the Bluesky protocols, i.e. the interfaces that I mentioned earlier. That's it. Any questions?
Any questions for our speaker? Maybe I could ask something quickly. What's your thought on the long-term roadmap for this in terms of what do you hope to accomplish?
What do we hope
to
say
a year or two from now, or are you planning on fully replacing V1 at Ophyd and with V2, or
not on any particularly intense timescale? I think what we plan to do is provide a solution for fly scanning that is not there at the moment, and start rolling it out across Diamond and NSLS-II. And that's pretty much it.
Okay, good. Well, let's thank our speaker again.